We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Rocket science is a field of science and technology that deals with the design, construction, and operation of rockets for various purposes, including space exploration, military applications, and commercial uses. The development of rocket technology has played a vital role in shaping our understanding of the universe, and it has opened up new avenues for space exploration. In this video, we will explore the basics of rocket science, how it works, and its importance in space exploration. But first we should know, the origins of rockets are believed to date back to ancient China, where a type of firework called fire arrow was invented. These early rockets were made by attaching a bamboo tube filled with gunpowder to the end of an arrow or spear and lighting the fuse. However, the person who is widely credited with inventing the first true rocket was a man named Wan Hu, who lived in China during the Ming Dynasty in the late 16th century. According to legend, Wan Hu built a chair with 47 rocket tubes attached to it, with the intention of using the rockets to propel himself into space. He reportedly sat in the chair, lit the fuses, and was launched into the sky, but unfortunately, the rockets exploded and Wan Hu was never seen again. While the story of Wan Hu's ill-fated attempt at spaceflight may be more myth than fact, he is nonetheless regarded as one of the early pioneers of rocketry, and his legend has inspired generations of scientists and inventors to push the boundaries of what is possible in space exploration. Rocket science is a complex field that involves the application of various scientific principles and technologies. At its core, rocket science is based on the principle of action and reaction, also known as Newton's third law of motion. This law states that for every action, there is an equal and opposite reaction. In the case of rockets, this means that the force generated by the burning of fuel in the rocket engine creates a reaction force that propels the rocket forward. The rocket engine is the most critical component of any rocket. It is responsible for generating the thrust required to propel the rocket. Rocket engines work by burning fuel and oxidizer in a combustion chamber. The resulting high-pressure gases are expelled through a nozzle, creating a high-velocity exhaust stream that propels the rocket forward. Rocket engines use various types of fuels, including liquid and solid fuels. Liquid-fueled engines are more complex and require more advanced technology, but they offer higher performance and more control over the engine's operation. Solid-fueled engines, on the other hand, are simpler and less expensive but offer less control and lower performance. The design of a rocket is also critical to its performance. The shape and size of the rocket determine its aerodynamics and stability during flight. Rockets must be designed to withstand the extreme conditions of launch, including high acceleration, vibration, and temperature. They must also be designed to carry the payload, including scientific instruments, communication equipment, and human crews. Rocket science has played a crucial role in space exploration. Rockets are used to launch satellites into orbit, explore other planets, and conduct scientific experiments in space. They have also enabled human spaceflight, allowing astronauts to travel to and from space stations and even the moon. The development of rocket technology has opened up new frontiers in space exploration and has helped us to better understand the universe and our place in it. There have been numerous rocket models developed throughout history, with varying sizes, designs, and contributions to space exploration. Here are a few examples. Saturn V, developed by NASA in the 1960s. The Saturn V was one of the most powerful rockets ever built, standing at 363 feet tall and weighing over 6 million pounds. It was used to launch the Apollo missions to the moon and played a critical role in the space race between the US and the Soviet Union. Falcon 9, developed by SpaceX. The Falcon 9 is a reusable rocket designed for commercial space launches. It stands at 230 feet tall and is capable of delivering payloads of up to 22,800 kilograms to low Earth orbit. The Falcon 9 has been used to launch numerous satellites, resupply the International Space Station, and even launch the first private crewed mission to space. Soyuz, developed by the Soviet Union in the 1960s. The Soyuz rocket has been in continuous use for over 50 years, making it the most reliable rocket in history. It stands at 162 feet tall and is used primarily for launching crewed missions to the International Space Station. The Soyuz has been used for over 140 crewed missions, including the first human space flight and the first woman in space. Atlas V, developed by United Launch Alliance. The Atlas V is a workhorse rocket used for a variety of missions, including national security launches and scientific missions to explore the solar system. It stands at 191 feet tall and can deliver payloads of up to 18,810 kilograms to low Earth orbit. The Atlas V has been used for over 80 missions and has a 100% success rate. Delta IV, also developed by United Launch Alliance. The Delta IV is a heavy-lift rocket used primarily for launching national security payloads. It stands at 206 feet tall and can deliver payloads of up to 13,810 kilograms to low Earth orbit. The Delta IV has been used for over 30 missions, including launching the Mars rover Curiosity. These are just a few examples of the many rockets that have been developed and used throughout history. Each rocket has its own unique capabilities and contributions to space exploration, and they continue to push the boundaries of what is possible in our quest to explore the universe. The development of rockets spans thousands of years, from the invention of the first rocket-like devices in ancient China to the modern rockets used for space exploration today. Now let's see the history of rocket development and the challenges it has faced. Early rocket development. The earliest known rocket-like devices were invented in ancient China during the 9th century. These early rockets were used for military purposes and were powered by gunpowder. Rocket technology continued to develop over the centuries, with various designs and uses, including fireworks and signaling devices. Modern rocket development. The development of modern rockets began in the early 20th century with the work of pioneers such as Robert Goddard and Hermann Oberth. Goddard was the first to successfully launch a liquid-fueled rocket in 1926, and Oberth's work laid the foundation for the development of the V-2 rocket during World War II. After the war, rocket technology continued to advance rapidly, with the development of the first intercontinental ballistic missiles and the launch of the first artificial satellite, Sputnik 1, by the Soviet Union in 1957. This sparked the space race between the US and the Soviet Union, which led to the development of the first crewed space flight and the first moon landing. Challenges and cost. One of the biggest challenges facing rocket development is the high cost involved. Rockets require massive amounts of fuel and resources to build, and the cost of launching a single rocket can run into hundreds of millions or even billions of dollars. This has made space exploration and satellite launches prohibitively expensive for many countries and organizations. Another challenge facing rocket development is safety. Rockets are complex and dangerous machines, and accidents can have catastrophic consequences. The explosion of the Space Shuttle Challenger in 1986 and the loss of the Space Shuttle Columbia in 2003 are tragic examples of the risks involved in spaceflight. Future of rocket development. Despite the challenges, rocket development continues to advance, with new technologies and designs being developed to improve performance and reduce costs. Reusable rockets, such as SpaceX's Falcon 9, are becoming more common, which could significantly reduce the cost of space launches in the future. There are also plans for developing more powerful rockets, such as NASA's Space Launch System, which is designed to be the most powerful rocket ever built and will be used for crewed missions to the Moon and Mars. In conclusion, rocket development has come a long way since its early beginnings, and it has played a crucial role in shaping our understanding of the universe. However, the challenges facing rocket development are significant, including cost, safety, and environmental concerns. Despite these challenges, The future of rocket development looks promising, with new technologies and designs being developed to push the boundaries of space exploration even further. Finally, as we look towards the future, we can expect continued advancements in rocket technology, leading to new discoveries and a deeper understanding of our universe.